I'll be covering some, basically like an introduction to learning quantum computers. I recently earned a scholarship with IBM, which is a qubit by qubit. It's a qubit by qubit summer camp, right? It's like a month long, and it teaches people about quantum computers and actually has you program on a quantum computer. So that'll be cool. So I'm going to be covering a little bit about what we learned there. Not this stuff, but this stuff's just things that you can find outside. So for one of the first questions they ask, and they try to explain is, what is a quantum computer? I'll try to make these videos short as well, just because I know our attention spans have died because of phones and all that, and all these notifications designed to like hijack our brains, right? So anyway, what's a quantum computer? Search it up on DuckDuckGo if you want to remain, privacy, and you actually like your privacy. I recommend DuckDuckGo. Google will just sell your information to highest bidder. DuckDuckGo, you're anonymous from the get-go. Anyway, let's look at Microsoft's answer. Let's look at Wikipedia's answer. You can even look it up at YouTube videos as well. I mean, you're already on here, so might as well get some info from other sources. Always question everything. Never assume that whatever anyone's telling you is the correct thing, because it's not. It's all bias. Anyway, there we go. Okay, so Microsoft Azure. What is a quantum computer? It's the use of quantum mechanics to run calculations on specialized hardware. Okay. What is quantum? Quantum computing refers to quantum mechanics that the system uses to calculate outputs. In physics, a quantum is the smallest possible discrete unit of any physical property. It usually refers to properties of atomic or subatomic particles such as electrons, neutrinos, and photons. And then it covers what's a qubit, which is basically different from classical bits, which are only represented in binary and can only hold 1 or 0. A qubit can hold a superposition of all possible states. So, for those of you that are really into math, basically you can search infinity a lot faster with a quantum computer. Quantum computers harness the unique behavior of quantum physics, such as superposition, entanglement, and quantum interference. Apply it to computing, introducing new concepts to traditional programming methods. Now, superposition is quantum particles are a combination of all possible states. They are fluctuated until they are observed and measured. So observed and measured. That actually has a lot to do with if you've ever heard of Schrodinger's cat, being both alive and dead at the same time. One way to picture the difference between the binary position and a superposition is to imagine a coin. Classical bits are measured by flipping the coin and getting heads or tails. However, if you were able to look at the coin and see both heads and tails at the same time, as well as every state in between, the coin would be in superposition. And then entanglement. Entanglement is the ability of quantum particles to correlate their measurement results with each other. When qubits are entangled, they form a single system and influence each other. We can use measurements from one qubit to draw conclusions about the others. By adding and entangling more qubits in a system, quantum computers can calculate exponentially more information and solve more complicated problems. Quantum interference is the intrinsic behavior of a qubit due to superposition to influence the probability of it collapsing one way or the other. Quantum computers are designed and built to reduce interference as much as possible and ensure the most accurate results. To this end, Microsoft uses topical qubits, which are stabilized by manipulating their structure and surrounding them in chemical compounds that protect them from outside interference. So that's a little bit like of what Azure thinks of. What am I doing on time? It's about 5-minute video, so I'll try and end it real quick here. This is just Azure's talking about it. So this is Microsoft's answer. I'm going to cover IBM's answer, and then I'll also cover Google's answer to this question. What is a quantum computer? There's different sectors that a quantum computer will be mostly used in, because it can't be used in everything. Some problems classical computers can do just fine. Most of the problems that a quantum computer will be used for are like, you know, simulating proteins, photosynthesis, superconductivity, complex molecular formations, so like protein synthesis or drug synthesizing. There's like a company called Recursion in Ogden in Canada. Sorry, not Ogden, in Utah in Canada. And they basically research potential drugs through machine learning, so that basically a quantum computer could do that a lot faster than their classical computers. Cryptography is a huge portion, so like cybersecurity will definitely be changed by quantum computers. Optimization, and then quantum machine learning. So definitely check this out. It's azure.microsoft.com. I'll try to provide a link in the description for y'all if you want to read it on your own. Since this is, I'm trying to stick to like the 5 to 7 minute videos for learning, I'm gonna stop this video here. I hope you enjoyed like a quick overview. Again, this is just Microsoft's answer. I will be covering other answers to this, and I'll come back like